Hello and welcome. This is a continuation of our networking series, and in this video I'm going to show you how to configure redundancy using the Cisco proprietary protocol, which is called HSRP, Hot Standby Router Protocol. So at the minute we have one device that connects us to the internet. So the web server here is actually representing the internet. We're connecting from our edge router. We're going through the network through a service provider, and then we're reaching that service. Here I've got a client, and that client gets a DHCP, TNS, all these configurations from this server. This server will provide the details of the gateway as well as the IP address. So if we check this machine and have a look at these configurations, we see it's getting a DHCP 10.1.1.11, and that's the default gateway, 10.1.1.2. This is the DNS server. So we're getting this IP as a default gateway, and what we want is actually test the connectivity all the way from this PC, going through that gateway, exiting there and reaching the server over there. So this server is in the subnet 30.1.1.0. So let's see its configurations. So that's the IP 30.1.1.100. So let's check the connectivity from that machine and let's ping it. So we have ping 30.1.1.100, and we're reaching that server. We also have a test page HTML site. So what we want to do to see if you can access that. The IP is 30.1.1.100. We haven't configured the DNS for that yet. So you see we're reaching that machine. But what happens if this device goes down? Then the connectivity of all these services will go down. So you decided a redundancy configuration where if a physical device fails, then the connectivity from the clients do not get disrupted. So we're going to introduce another router, and that router will be the same as the one we have. So let's grab one of the similar. So we deploy it here, and we can call it router 2. Let's call it router 2, and it has two interfaces which we want to connect, one to the local LAN and one to the external. So this switch is external switch, and this is our internal switch. So let's connect the cables. So if I reduce the size of this, so we have a cable here, and if we grab fast Ethernet, so maybe number 2, connect to fast Ethernet 0/0, and then connect the uplink 0.1 to that switch. Now we have one device that's added, and the connectivity is not configured yet, but we have at least something in place. So let's make it a little bit diagonal. Okay. So you have this device introduced to the system, and we need to give it its own IP addresses. So if we configure, first of all, let's rename it. What we renamed earlier was just the display or a label, but we need to do the configuration as well. So let's go to enable, conft, and host name. Let's call it router 2. And then we've got two interfaces. The first one is the local, so interface, let's call fast Ethernet 0/0. We will give the local network, which is IP address 10.1.1. Let's give it 3, and it's /24. So, and then we enable that. So this interface should be coming up. Let's have a look. So the switch takes the spanning tree time, and then we go the other uplink. So if you go exit this interface and then provide an IP to the second 0/1 interface. So the IP for that subnet is 20. So let's just change that number and also say no shut. So the uplink also is connected, but to connect to a service on the internet, it needs a default route, and that's the default route here. We're going to configure, if we exit, say IP route. So any network that we don't know, send it to the router up there is called 20.1.1.5. I'll show you its IP. So this is the interface for the ISP. And when we provide that default route, if we exit, let's try to ping the server now. and the server was 100, and we should get response. So we missed the first one. The 4 following that are successful. So if we repeat, we have full connectivity. That means this router is fully configured to reach off to the internet. But then it's now a problem. These devices, they have a default gateway of 10.1.1.2 because that was the only router they had, and this router is here. So if we check its IP, this router has fast Ethernet. Show IP interface brief. So you see the IP we have there is actually .2, the local and the external. But if this is the only thing that they know. They don't know about this. So now we're going to introduce the redundancy. So what's the redundancy? We will give a virtual IP that both can use. Whichever selected as the active will be managing the virtual IP we will use. So we need to go to the interface, let's say the local one, fast Ethernet 00, and create the redundancy. So if we go to interface fast Ethernet 0/0, then we have to create the commands for the redundancy, and that for HSRP we call it standby. Then we have to give it a number, and this number, depending on the version, we use in version 2. Actually, let's first choose version 2, and you can read the difference between version 2 and version 1. Many features added to version 2. So here we have now standby version 2, but then we need to create a number. So let's call that number is called the group. You might have some interfaces, for example, the local interfaces, the LAN, they may be a group. External ones, they can be another group. You might have different groups on one router. So we have to define the number, and that number is in this range. So I'm going to give, let's say, the VLAN 10. Here we use it. Let me call it 10 so I can remember it easily. 10. Then I'm going to give the IP, which is the virtual IP, 10.1.1.1. If you remember, the physical interface for that router was .2, but the virtual is 1. This is the one we have to configure on both routers. So whichever is active will be handling this IP, which will be a gateway for the clients. So let's finish that. And then it goes into stages. So after the initializes the selection of the active one and standby one, when that's done. So for this router, we can also create standby. The number we created was 10. If we want this machine, whenever, for example, this machine goes down, and then the second machine takes over. So the traffic is going through that. But then you fix the problem of here, and whenever that machine comes back, you want them to be the active machine. So we create something called preempt. So let's create and standby 10. The number should be consistent 10, and then we create preempt. Okay, so that's all we need. Now that configuration for the internal interface is done. So if I say show run, you see the interface has now some things added. It has the standby version, a group with a virtual IP, and preempt. I also want to configure the external interface, the one facing the internet, and let's go to that configuration and say interface fast Ethernet 0/1, and then we create the standby version 2, and then standby, this one we call it 20, and the IP, the virtual IP is going to be this. And so IP we forgot, so we have to add IP 20.1.1.1. When we do that, we can create the preempt standby 20 preempt. So this router is always the preferred one. We exit. Let me show you the configuration. So both interfaces are configured with the virtual IP. Now we need to do the same for the second router, and we can just copy the configuration, but preempt is configured there, so be careful. So we have to configure this one and say interface fast Ethernet 0/0, that's the internal, standby version 2, standby let's call 10, the VLAN 10, and then we give an IP 10.1.1.1. If you see, this IP is configured on both routers, and we're not creating preempt. This one we make it less preferred. Then if we exit this interface and go to the second interface, that's .1, and then we create the version first of all, and then we create the IP for our the virtual IP. So we call it 20.1.1.1, And when that completes, then we exit and save the configuration. If I show you, then you see both have the version. So you see the IP is actually configured on here. It's also configured here. But now these machines, they still see the default gateway as .2. We need to change. That's changed from the DHCP server. So if we go to the DHCP server, and if we go to here, and if we select this pool, now we need to change the default gateway, and we make it 1. If we save it, and now if we flap the interface DHCP, then we should get .1. This machine now, if we ping the server, will still be working. So let's say ping 10.1.1. The server is 30.1.1.100, and that's it. Now if I show you that server, but in a simulation mode, if I see the traffic coming from here, if I ping the server again, I'll show you what route it takes. Let's enter, and if we minimize this, and if I make it a bit faster, so you see ping comes out from here, it will go to the that one is the primary one, and then that primary will route it to the uplink, and that takes to the gateway or the default route, and that router now understands where the server is. It forwards to the server. Server now responds because the default gateway is configured as this router. The server now, sorry, the router, the ISP will respond. Okay, it understands where that traffic came from. It sends back to the switch. The switch now sends to the, so that's the first packet. So if we check, the first packet succeeded. Now while that's happening, if I disable this router, let me power down this router, and if we power it off, you see that link is now down, but we need this communication to continue. So the traffic, when it's sent, it will select route it takes. So that completed actually. Let's do it again. Okay, so we see now traffic initiated from the PC. That route is now down, but the route will be changed to router 2 because in HSRP the virtual IP as a default gateway is already here as well. So this takes care of it after the updates, and then that sends to a destination. The destination now responds, and when the response comes, it will be forwarded again to this router, and that router will forward back to the local device. So if you see a problem like that, maybe there's a configuration issue we need to check, because you see the traffic was sent to here and then it came back. This doesn't know how to return it. So what happened to that packet? Let's check. When I was doing the configuration, actually I made a mistake. When I was creating the HSRP, I gave group 10 for the local interface and group 10 again in the external. Now I changed that, so please, if you were following along, correct that. We have the .1 as the VIP IP or the virtual IP of the HSRP group for the internal. This machine will forward its ping packet to the IP. Then whichever device is active will take that traffic and forward it to a destination. We now switch it off that router, and we're expecting this traffic not to be disrupted. It has to go through whatever active machine that's available. Now let's see the ping traffic. So I need to initiate a ping traffic. So if you see now, the ping traffic will go to the VIP, the virtual IP, and since that one is down, this router will take care of. So we're looking at the greenish yellow packet, and it goes to the destination. Now the destination knows how to respond back, and then it will come to this router. So let's see what that switch does. That link is down, so it's not going to send anything. It will send to here. This will forward to the destination switch, and the switch knows where that source came from. It will be received here. And now if we send the second packet, but as you know, there will be updates in the network as well. So if you see other packets going through, ignore those. Otherwise you can study what packets these are. But what I'm after is only the ping packet. So we've done 1 The second one hasn't been done yet. So you see the response came, that was successful. Let's wait for the second. That's the second one starting. The olive color one, that goes to the switch, which knows where the router is. Router now knows the destination to forward to. It has a default route configured. It goes to the ISP router. ISP router knows the destination IP, which is the server. Server now responds and then comes to the gateway. Gateway is the ISP. It now forwards back to the switch here, and the switch knows where the traffic came from to the router. Router sends back to the destination, which is at the end, and then it will be ticked. So you see, if I now bring this back, if I switch on this router, if I switch that on, because we created preempt, it will take some time for this machine to come up. When it's fully up, the preempt will take over this router and make this one active. This will be the secondary one. This will be the primary. So the traffic will be routed again through here. Okay, so now we introduce the second router, and here on the right hand side you have its configuration. What they both share is the VIP IP. So the VIP IP for both interfaces, one facing the internet and one facing the local LAN. And the group is different, so that's VLAN 10. In the previous configuration I made a mistake where I put this one as 10 and they were all same. Then I corrected it. So here's the full configuration. The local LAN interface, that's the physical interface of the router itself. And for the second router we have this IP. Then they both share this VIP or the virtual IP. But here on the left, the difference is I created a priority of 150. The default priority of HSRP is 100. But if you change to a higher number, this will be the active HSRP router. And also I put the preempt. So if this router goes down, this takes over. Whenever this comes back, then what happens is this will become standby and this will come back as a active. So preempt gives authority this to overthrow whichever router that comes active in the interim. And then we do the external interface, also higher priority with preempt, and the group is 20. Both of them, they have a static route pointing to the server, which is hosted on the internet. So that configuration is now ready. If we save it, and if I check this one as well, let's check. Okay, both are saved. Now the second thing to do is a test of how these clients reach the server. So let's ping the server. Ping that server is 30.1.100, and that's reachable. But how are we reaching? Are we going through this router or are we going through that router? We have a default gateway which is .1, and if you remember, the .1 was the VIP, which is shared by 2. Whichever router that's active will be managing the VIP as well. So here, if we check the IP and say IP config, you see the default gateway is not the physical IP of any router. This is .2, the other one is .3, but here we have .1, which is the VIP. Now, if the router goes down, it doesn't matter. The clients, their connectivity won't be disrupted. So let's see, how do we reach the server now? Trace RT and 30.1.1.100. Which route are we taking? And it shows you, we're taking the default gateway .2, which is this router, and that router's interface, as we checked, was here. So it's taking that route and then exiting to that server. And so if we check, then it goes to the next hop, which is the fast Ethernet for the ISP router, and then it reaches the destination. So we're taking the left route. Now I want to show you in a simulation how that traffic works. So let's try a ping test to the server 30.1.1.100 and then see how that packet is handled. And we make it a little bit faster. So we send a packet. The router receives it. It took that route. Then it's forwarded to here. Goes to the destination. Now the destination responds and then it comes back to the ISP router. ISP router will send it back to us. And then this will say, I am not the primary. This is the primary. That will handle the traffic and traffic goes back. So that's one packet. Let's stop the simulation. This is how you create redundancy and HSRP, which is a proprietary protocol for Cisco, but you can use VRRP, which is a standard for all the vendors. So here you go. Thank you for your time and see you in another video.